Hello everyone, myself Rani, working as Assistant Professor in MLR Institute of Technology in Cyber Security and Data Science Department. In today's session, we are going to discuss about number system in Python. So, overview of the presentation is decimal, binary, octal, hexadecimal. Here, how we are representing all these number systems in Python, we will see here. So, decimal, binary, octal, hexadecimal number. The system can't understand the decimal number system. We need to convert that into the binary number. That's why we need the converters, compilers are there also. So the decimal system is the most widely used number system. We are doing the mathematical calculations with the help of the decimal system only. But we need to convert that decimal system into the binary for understanding of the computer. So the binary, octal, hexadecimal number systems are closely related, and we may require to convert decimal into these systems. So here we are converting decimal to binary, decimal to octal, and decimal to hexadecimal also. So the decimal system is base 10. So decimal system, the base contains 10 and it contains the 0 to 9. Means 0 to 1, 2, 3, so on 9. And the next one, the binary is represented with, it contains two values only, that is 0, 1. So base 2. And octal contain only 8 values. So the base is 8. So the values are 0, 7. 0 to 7. And the next one, hexadecimal. Hexadecimal is 16. So it starts from 0 to F. So these are the bases. 10 represents for decimal, 2 represents for binary, and 8 represents for octal, and 16 represents for hexadecimal. So in Python, a number with the prefix 0b is considered as binary. So in Python, if you want to understand the binary, means it is represented with 0b, means binary number. The next one, 0o, it is the octal representation. The next one, 0x, it is the hexadecimal representation. So here I given one example, 60. The decimal number is converted into binary number, and the decimal number is converted into octal number, and the decimal number is converted into hexadecimal number. So prefix is 0b, means it is the binary value, 0 means octal value, 0x means it is the hexadecimal value. So here, if you want to convert the decimal number into binary number, so binary number means the base is 2. So the 60 is divisible by 2, means 30 times. And again the 30 is divisible by 2, 15, 0. Next, the 15 is not divisible by 2, but 14 is divisible, and the remainder is 1. And now 14 is divisible by 7 here, 3 2 times, and again 1 remainder is there. 2 is not divisible by 3, so it is divisible by 2 only, 1 time and 1 remainder. So we are following the bottom up approach, bottom up. So the binary value is 11100. So it is the binary number, bottom up approach 11100, and so we have to prefix with 0b. The next one is we are converting the decimal number into octal number. So here 60, octal means we are representing with 8. So it is divisible. So 8 is divisible by 60, means 7 times. So 8 sevens are 56. So we'll get remainder 4. So 8 is not divisible by 7. So we'll get 0 and the remainder 7. So 74. We are following the bottom up fashion only. 74. Octal number 0o74. Next one, hexadecimal representation. 0x3c means 60. So we are dividing with the 60 with 16. So the 16 is divisible by 3 times, means 48. 48 means the remainder is 12. So in the hexadecimal, 12 is represented with C. Now the 3 is not divisible by 16. So we are writing 0 and 3 here. So we are following the bottom up approach. So 3C. So this is the hexadecimal number. So in this way we are converting decimal to binary, decimal to octal, decimal to hexadecimal. So now in this also we are having the float type. Here what we are doing is we are converting the integer to float. So this function is used to convert any data type to floating point number. Here we are converting to integer to float. So I am taking s is equal to 2. So it is the integer value. Now I want to convert the data into the float type. So e is equal to float of s. So we are converting the s value. The result is 2.0. In this way we are converting the integer to float. Next one, if you want to convert the decimal system to octal system or binary system or the octal hexadecimal system, we are having the built-in functions are there. Those built-in functions are hex. Hex number, you have to specify the decimal number. It simply converts the number into hexadecimal. So this function is used to convert integer to hexadecimal string. So here I took C is equal to hex of 56. This is the decimal number. So I am converting into hexadecimal. So the hexadecimal number for 56 is 0x38. The 0x prefix is representing for the every hexadecimal number. The next one, oct. This is used to convert the integer to octal. So we are converting the integer number to octal. So for that we are using the syntax. It is a built-in function oct. Oct number, the syntax for converting the integer to octal number, oct of number. So here you have to specify the number. It converts that number to octal. So C is equal to oct of 56. Again we took the 56 value only. I am converting that to 0070. So with the help of built-in function, we are converting the decimal number system into octal. The next one, str of. So here we are converting the whatever the data it is, we are converting it into string. So with the help of the str of. Str of is nothing but it is used to convert the int of means we are converting into int, float, hex and oct. Like that string also. Here also we are converting the integer to string, float to string, like that. So C is equal to str of 1. So it is 1 is the integer and we are converting it into st. String type means it displays the C value as 1. Double quotations means whatever the value we are giving, so it will be defaultly. If it is a value, it is taking it as an integer. If it is a pointed value, it is taking it as a float. If it is a double quotation value, default it is taking it as a string. If it is stored in the double quotation means it is a string. So C is equal to str of 1 means here the 1 is we are converting forcefully, explicitly converting into string type. So after converting specified value to string, so the string value is 1. Next one, complex. Here also we are performing the type conversion. This function converts real numbers to complex. So if you want to convert the real numbers to complex, we are using the complex of real comma imaginary part. So the first part the first value it is taking it as a real. The second part it is taking it as a imaginary. So C is equal to complex. 1 it is taking it as a real and 2 it is taking it as a imaginary. So after converting it displays 1 plus 2g. So the basic form of complex number is a plus bg. So the a is the real value, b is the imaginary value. So with the help of complex function, we are converting the real numbers to complex numbers also. These are the built-in functions. The next one, char number. So this function converts number to its corresponding ASCII character. So already we discussed about ORD. So the ORD function used to convert character to value, but it is the reverse of CHR is here we are converting value to character. So, for example, the syntax for char is, here we are converting the character number to the particular character with the help of ASCII notations. Char of 76, char of 65. Char of 65 means capital A. Char of 66 means capital B. So here we are taking the number and we are converting it into ASCII number, ASCII character, that is L. 76 is representing with capital L and char 77 means capital M. So the char function is used to convert the number to ASCII character.